My name is Michaela, and with me today I have Sam and Maria Fransson. This webinar will be recorded as well, so you will be able to see this after if you miss anything. Shall we start?
Yeah. Hello and welcome to the first webinar of 2022 from Swedish Exergy. I will be talking about a few important aspects of biomass in this webinar. We'll be covering the points in this webinar in order. What is biomass and why to dry it? Safety issues with dehydration or drying processes in the generally available market. Emissions related to the dehydration process, CO2 footprint from the dehydration process, energy consumption. Exergy superheated steam dryer, we will touch upon a little bit why, and also why steam is good for dehydration process and how steam can be used for drying, because it sounds like that the opposite of what steam does. It doesn't make wet, it dries with our technology. Swedish Exergy is a company based in Gothenburg on the west coast of Sweden. The technology, what we call it today, Exergy PSSD. Exergy pressurized superheated steam drying was invented at the Chalmers Technical University by Claes Minter, the founder of this company, started the business in 1979. Also, the first dryer was built almost the same year when the company started and research was still ongoing. That dryer was for drying paper pulp, still operable today after about nearly 40 years of running. We are a full service company to provide from the concept to completely commissioned plant and beyond, which means we also provide after sales service. In the circle, you see our focus areas for our business applications. We start with biomass, today's topic. We also work with animal feed, ethanol for both first generation and second generation parts in different parts of the production process. Pulp and paper. Production of market pulp is one of the big applications that we work with. Sludge coming from different industries and from municipal water treatment plants, which of course can be converted into energy, and also the chain of sludge getting used for fertilizer or other things, when transmitting the heavy metals and other damaging compounds back to the food chain is broken, because we take care of that by combusting the dry sludge or by pyrolysis process. We can make biochar, other products, other energy as well. Agro food, it's more related to applications like sugarcane, bagasse drying. It is also related to the sugar pulp drying and some other applications which are related to food. Yeah. What we provide, let's start with, for example, when we get in touch with you or you get in touch with us, we talk about your application. What is your problem that we can solve together? We can verify application of our technology by doing pilot plant tests, which we have, which works on continuous basis, so full simulation is possible. We can do a feasibility study for you to make investment decision. If we go further, we can do design engineering, project management, equipment manufacturing in our own workshop and our partner workshops. We do purchasing for the projects. We do site installation and support. We provide training to your operators, to the maintenance staff, to the plant commissioning. We also provide inspection services after the plant has been started and over, either early inspection or true early inspection, where we can make a joint inspection of the plant and make a list of maintenance issues, other things to be fixed, by making the plant availability as high as possible. We also provide after-sales service, that's the last part, where you get spare parts from us, you get a site service from us if you need it, if you need our engineers to make any kind of adjustments or work with your maintenance people to improve the plant efficiency, working, and other aspects of the plant during the lifetime of the plant. And as we will go through more, our more focus, or very high focus, is on sustainability, which means our plants are very sustainable in terms of not just the production, but also lifetime. We're talking of lifetime of 35, 40 years of plant that we deliver. You have a lot of benefits with our system that offers. And our focus is, of course, the efficiency, which is energy efficiency, quality of delivery, our expertise in these application areas and beyond, and sustainability, which I touched upon before. So we are a company who can support you all the way from start to finish. What is biomass? There is a lot of debate going on currently around the world and all of the countries concerning the climate change, the effects of the emissions that we are making from the fossil fuels. How can we mitigate it? Biomass is one source that can help mitigate CO2 emissions or the carbon emissions in long term. Look at perspective of between 10 to 50 years. Sweden is a leading country when it comes to biomass utilization for energy production, both in terms of heat, especially and the power as well. Of course, we make a lot of products from biomass in this country, from the wood, from paper pulp to making products for house making, all kind of things. And we also are able to produce a lot of biomass for energy production. Almost 40% of the energy requirement of the Sweden comes from biomass, which is a very big chunk of energy that is produced from biomass. So it is sustainable. So there is no question about biomass not being sustainable. There's a debate going on that biomass must be kept in the forest, not used as energy or for production, because it absorbs CO2 and reduces CO2 effect. Yes, that's correct. That's only short-term thinking. If you think long-term and make it sustainable in terms of planting new biomass or new trees and harvesting the old ones and make a cycle. In Sweden, for example, north of the part of India, the cycle is around 100 years from plantation to utilization. And we have managed to create this cycle very, very successfully in this country. And this can be replicated in many, many countries where biomass grows much faster than it does in Sweden, for example. We have very dark periods here, we have cold periods here, so the plant growth is not very, very big here, but still it is sustainable fully. Biomass can come from any kind of plant. Could be trees, could be other things. And it is sustainable, as I said before. So we are focusing on that. The common feedstocks that are being used for energy production is wood processing residues, which could be coming from manufacturing, from sawmills, from other areas. Forestry residues, when you harvest the plant, there are a lot of parts of the plant that is not going to the paper pulp making or for wood making. Then the rest over can be used as a biomass for energy production. Energy crops, lakes, and other plants that are being used mainly for energy production. Agricultural residues could be from the wheat straw, rice straw. Rice husk, all kind of biomass can be used for making energy. And waste from industries, farms and households. This is also a good biomass provided it is processed further. sludge, for example, coming from the water treatment plants is a biomass, and energy produced from the sludge is classified as green. It is making the system circular as well, and is making the environment more safer from reducing the streams like heavy metals going into the water or into the food chain, through the fish or through the meat or through the milk, whatever we are producing from that. Why to dry biomass? When if you talk to a boiler company, ask them to produce a boiler for you, you can get an answer that we can burn 60%, 70% moisture content feedstock in the boiler. Correct. You can feed 60% or 65% moisture content to the boiler, but water does not burn. This is a fact. You cannot burn water. You have to evaporate the water, remove the water from the biomass before you can burn it. And removing water in a furnace, in a boiler, is the most expensive dryer that you can build, because it makes the flue gas quantities the minimum choice as much as it should be, because density of water vapor is 0.6, density of flue gas is 0.9, so making twice as much as flue gas than you should be making if you burn dried biomass. You need a bigger furnace, you need a bigger boiler, you need a higher capex, and the overall efficiency of the boiler is much lower if you are burning wet. So one reason is to dry is to increase the overall efficiency of combustion of the boiler. So you can produce more energy from the same amount of biomass, because you don't have to use the energy in the boiler to dry it. Of course, drying needs energy, but that can be done very, very effectively using Exergy PSSD, for example, that is one technology with a very low amount of energy. And of course, the lead water vapors we talked about in the furnace, and also when you burn wet, your emissions are much higher from the boiler. It's a fact, and you can reduce that by burning more dry wood. And of course, if you are producing a product out of biomass like pellet, like other products which needs transportation, then you can densify to increase the density of the biomass, which will of course reduce the cost of transportation, and you don't have to transport water longer distances. That transporting water doesn't make any sense by using fossil fuels, emitting a lot of carbon on the way when it's being transported from one to other place. So you can reduce that cost, but then reduce the carbon footprint of the transportation part. So let's see if some of you have would like to raise your questions or your concerns or your issues today you have in your biomass production or valorization process. You can send as a
You can send it as a question.
Yeah, as a question, as a message. We can take it up in the due course as we move forward, discuss it jointly, or you're also welcome to contact us after the webinar via email with questions and problems that you'd like to discuss with us. We're very happy to take another Teams meeting, video meeting, or through email correspondence. We try to help you out on this issue. So we now go through a little bit of safety issues and discuss briefly about the existing technologies on the market for dehydration. And on the screen, you see a statement from a magazine, Ethanol Producers Magazine from the United States, where they have made the statement that all dryers on the market will catch fire. And anyone who says differently is a little too optimistic. And it is absolutely correct for all dryers that operate with air, that operate with high temperature flue gases. Those are the most common dryer technologies in the market, and they do catch fire, they do explode, they do create a lot of problems. So this statement is correct for that, but we will come to it how we can eliminate it completely, this and make this statement other way around, that Exergy PSSD does not burn and does not explode. Here we can see from the same magazine had made a study and made this stable diagram to show the economical effect of the losses related to the drying process. And related to that is the off-gas treatment process in states where you have to have it called RTO, regenerative thermal oxidization, where you must treat the off-gases to remove or to destroy the VOCs from the off-gases from the drying process. So you can see those two that are related to the dryer or drying process are the most cost-causing components in the production process compared to other things that are, of course, the tanks and vessels is another storage area that's quite far. But the dryer and RTO is the major cost, and also it's not just the cost of the plant, it's also cost for insurance, the safety issue that's being operated for operators, and other things as well. Yeah, so this is quite a thing that is a problem that can be solved with us. The emissions from the dehydration process, this is related to the existing ones on the market, based on air or based on flue gas, which are working directly with the drying material, let's say biomass being dry. Particulate emissions is of course there. You have VOCs that's coming out because it's being extracted and emitted to the atmosphere. From the combustion systems, also comes out NOx, that is of course there. We have CO2 emissions from the energy production process for drying, and with all open dryers, which are using air or flue gas, you always have emission coming out from the dryer, and moist air, especially during the winter time, is visible like a plume that you see from a distance. And in high temperature dryers with flue gas, you can see also blue haze in some periods, which is of course not good for the atmosphere and also not good for the people living around the system. There are a lot of protests from people who see this kind of emission from the drying process, which is perceived as to be not healthy. Even if all cleaning has been done, you have taken care of VOCs, you have taken care of particle emissions, everything, but it is still something visible that is seen. And all these must be taken care or treated one way or the other, and it all costs money. So sometimes with the traditional dryers, the cost of drying is one, then the cost of treating the off gases could be as much as the drying process itself in terms of energy cost. And for installing RTO, for example, you have a biomass burn dryer, you need natural gas to increase the temperature of the off gases to 70 degrees Celsius, just like heating up everything and then letting it out, because you must destroy the VOCs, and that takes the temperature to destroy it, to burn everything. So that's a huge cost. Then in terms of energy consumption, this is a very simple presentation of 3 different technologies, common ones in the market, 2 of them, pellet dryers and drum dryers, and our Exergy PSSD. So if you look at electricity consumption, it's more of the same for us and for other people in the market, other technologies in the market. But when it comes to the heat consumption, then it is only 0.15 megawatt hour per ton evaporated water, wherein we can recover 90% of the energy that goes into drying as low pressure steam, as compared to up to 1 megawatt hour per ton of evaporation for the normal dry. So we're talking about energy consumption close to 15% of what other people are, other technologies are needing. And also with our technology, we can make your drying process completely free from heat uses. We can use 125 to 150 kilowatt of electricity to run the entire dryer instead of using any type of thermal energy. So why Exergy PSSD? Why our technology is a preferred technology, or should be preferred technology for dehydration of biomass? One, we just looked at the energy consumption, which is very, very low. Recovery of energy as pressurized steam, of course, it's a high value energy that can be used for process heating if we are integrated to a process, for example, in an ethanol plant or in another plant. Can be also used for distributed production in the colder countries. It can be used for power production, the areas where we can make power from the steam. And with power prices, energy prices increasing like anything at the moment, and it's likely to continue to be at high level, production of electricity from the dry steam is a viable option. And of course, low consumption of energy is very, very important for your total production cost. To increase your margins on your production, it is harder to increase the price of pellet than try to reduce the production cost and increase your margins. No emissions to atmosphere, because our Exergy PSSD is 100% closed, so there is no emission coming out to atmosphere. So we have no particulate emission, no VOC emission coming out to the atmosphere. And of course, no smell either. If you're processing products like sludge or other things that are smell-containing products, you could have this huge problem treating the off gases from smell. You need a bioreactor, you need a chemical dosing, you need scrubbers in the chemical to neutralize the smell-causing compounds, which is also an expensive and costly process. Then we have CO2 footprint, which we looked at the directly related to the thermal energy consumption, and we are offering 90% CO2 reduction for your dehydration process with recovery of energy. So this is a big benefit, and also not for your pocket, your bottom line. Of course, you get carbon credits now for not emitting carbon, but also for the climate change, for the atmosphere that we will be discussing today, to reduce the effect of industrial processes on emissions, especially the CO2 emission. And this we can reduce drastically, basically, from keeping the production processes intact, capacities intact, and not affecting that. And also, we can make the CO2 emission to zero if we can use only electricity, of course, provided electricity comes from sustainable sources, not coming from coal, then we have the zero emission from the drying process. And as far as we know, we are the only technology provider that can provide this option. We do not have any need of thermal energy. And water is scarce resource in many, many countries. It's getting even more important to conserve and preserve water. So if you're building a factory after you have a demand from authorities to have a low water footprint, and with our process, you can recover all the moisture that is in your product as liquid water, and it will recycle it back in the process. So you can reduce the water footprint as well, yeah, as a benefit. Then the process itself doesn't have a lot of moving parts. It's a fan and two feeding and discharge equipment. So basically 3 rotating machines in the entire plant, which means we have very low maintenance cost. We have a drying time of about 10 to 15 seconds, as compared to a few minutes in any of the comparable dry, like drum dryer could be a few minutes. On the belt, it could be up to 1 hour. But the product lies there and moves slowly forward when it's being pumped with hot air from the bottom, trying to remove the moisture. So you have tons and tons of material inside. It takes very long time to dry. We do it with very, very short time, 10 to 15 seconds. And with that, we also can maintain the moisture content of the product within very, very precise level, because we expose every particle to the same dry condition, which means they are being suspended or dispersed in the dryer before drying them. Whereas in a belt dryer, for example, you have a layer of material lying where the bottom part gets super dry, the top part still remains the wet, because the air as it passes through the bed gets more and more saturated. By end of the belt, it has been nearly saturated or is coming close to saturated. So it's not drying anything on the top, but it's drying a lot at the bottom. So you get very uneven dry product. That's why in pellet making, for example, after bed dryers, you need large storage of biomass, big silos, which are basically there to just balance the moisture from the most dry to wet, or other way around, from the moisture going from wet to try to even out. It's possible to get a better quality pellet. With our, you get precisely 12% moisture, pelletize it without storing anywhere in between. Basically, the pellet presses can be directly under the dryer, provided we can do the milling before the drying. Wet milling to the complete level, and then you can pelletize it straight away. Steam condition, ready to go pelletizing. Small footprint, we build on height. So if we're doing a retrofit on your plant, or we're doing a new plant, of course, the land is important and expensive. So you don't need a lot of land on the ground, built on height, compared to the drum or bed dryers, which need a lot of potential space to be placed on. We completely eliminate risk for fire explosion. Reason being, steam that we use as a drying media is inert. There is no oxygen. So by virtue of the technical process, steam being inside, 100% inert, there is no risk of fire explosion. It can never happen, which makes it safer for operation, and also your insurance premium will go down, because fire explosion is the biggest risk in the drying process, and the premiums are decided based on that in the industry. For some products like animal feed, food, even sludge, wherein we have got a bacteria of different kinds of viruses present in the product, and this can survive even after normal drying processes, because, like I said before, we are not drying everything, not exposing to high temperatures, everything. There are some pockets that are left with low temperatures, undried, and those will not be completely sterilized. We guarantee 100% sterilization with our process, because we are exposing every particle to high temperature, steam, and in this short period of 10 to 50 seconds, we sterilize the product completely. It's fully proven now. Life cycle cost we discussed before. We're talking about energy consumption, capex, and spare wear parts. So a period of 3 to 4 years, your dryer becomes much less expensive compared to a traditional dryer like pellet or drum, because their capex might be a little bit lower, but the OPEX in terms of energy consumption, spare wear parts, the cost of maintenance, the cost of insurance, other things make it that they continue to grow the cost. So over a 10-year period, we have saved a lot of money using our technology. We can also increase capacities if we know from the beginning. So expansion can be done easily with capacity increase up to 40%. We can provide without major modification in the plant. We can build the plants with large capacities. Of course, up to largest one we have executed and built is 130 tons per hour of biomass going through the dryer. Flexible design, which means it's an adaptable solution in terms of placing your feeding point, discharge point. We can adjust the height. We can have a location that is more suitable for the layout. So there is a bit of flexibility which we can adapt to your plant. Wherein, if you look at a comparative technology like pellet dryer, there is a fixed feeding point, fixed discharge point. You cannot do much about it. Similarly, drum dryer is the same. It's a fixed feeding point, fixed discharge point, wherein we can adjust the feeding and discharge height-wise and even XY coordinates also, the site-wise. So we can adapt to your plant design, which means you can save conveyors. You can also save other costs related to the layout and additional machinery. Steam. Why steam? Because air and flue gases work. So why we need to think different out of the box and use steam for drying process. Of course, we have learned benefits in the previous slide. about why you should use it, what are the major benefits. These are additional benefits that you get on the product, which we call it product quality improvements, process improvements that we get. One important aspect, if you're a pellet producer, is steam conditioning. Traditionally, when the traditional dryers are used, the pellet presses have a conditioner or conditioning unit before, when they put some water or some steam, condition the biomass before it goes to the presses. The idea is to soften the product and to make the moisture as even as possible when pressed into pellets to keep it good durability and good finish on them. We are conditioning the product with steam in the dryers. We do not need steam conditioning or conditioning section before the pellet presses, so we can feed biomass directly from the dryer to the presses. The quality of pellet also improves. You have lesser breakage, and during transportation, loading, unloading, the amount of dust that is produced is reduced as compared to the normally produced pellet cell. This could be a big benefit, and the losses can be reduced. If you can mix into powder, it's harder to handle it, and also it's lost for the process to take care of it. We talked about already precision uniform drying. Of course, that's also because we have steam, we have a dispersed atmosphere in the dryer. It makes it drying very even, very precise, because we're exposing every particle to the same condition, same temperature pressure condition in the dryer, and they stay almost the same in the dryer. So the residence time, temperature and pressure combination makes it that we can produce very, very even dry product. The opening of fiber structure may not be so important for the making the biofuel if you think about it, but when you are pressing the pellet, there is one compound that holds it together. The pellet is lignin, and lignin is inside the wood. And if you open the structure and you press to pellets, you are able to get some of the lignin on the surface, and it's where acts as a binder. So sometimes you need additional binders like starch, like other things, to produce good quality pellet. We can reduce the consumption of such additional binding or binders needed in pelletizing. Improved commercial properties. It's of course not because of the dryer itself, but okay, we're getting better quality pellet, I would say. That's most important. And of course, one very, very important aspect, which is very expensive for the money and for the life, is the fire explosion of drying process, which happens. And let's say if you have a drum dryer or belt dryer, where you have tons of material rotating or moving in a belt, if unfortunately you get fire in there, it's a lot of material in the dryer, it burns. It's very hard to get rid of the fire, and often the equipment gets destroyed almost completely if it gets to that situation. The cost of fire explosion in the different dryers is very, very high. We are talking about large dryers. Let's say we are processing 50 tons per hour of biomass, and inside the dryer, at any given moment of time, we have maybe 100 kilo material, because the time that we take to dry is only 10 seconds compared to minutes and hours with other technologies. So if the dryer stops, for example, there's a power outage, there's a blackout or something happens, somebody press emergency stop, you have 100 kilo material that ends up at the end of the process, at the end of the cyclone, which can be taken out without creating any big issues if that kind of thing happens. Also. So it is quite safe. Doesn't have a lot of material inside the dryer, and of course inherently safe from fire explosion, because we have inert media in the dryer, which is steel, of course, which cannot burn. The water does not burn. Brief view of the comparison from the conventional systems like belt and drum dryers, the most common ones in the biomass industry, to our Exergy PSSD. The capex, of course, we have the dryer. They also need a dryer, But other than dryer, you need post-gas treatment processes like PSSD, RTO, filters to get rid of all the particulate emissions, VOCs, odor problems, other things by adding these equipment at the end of the drying process, which we do not need. That's eliminated. We need only Exergy PSSD. The only equipment is needed. Then you have to also install firefighting and explosion equipment because you need to ensure that the fire does not spread or explosion doesn't spread and the damage is minimized. So you need a lot of fire detection equipment, fire quenching equipment, water systems, which have to be installed in order to even get insurance from insurance company. If you don't do it, you will not even get insurance for that. So these are the equipment that are needed to complete the drying or dehydration process, wherein with Exergy PSSD were complete just with one equipment dryer. When it comes to OPEX, we've already gone through this before in the previous slides and explained the cost of running the plant is very low. Energy consumption, we're talking about 15% as compared to the other technologies. Spare wear parts, very small. You have no other major cost to maintain the plant because it doesn't have a lot of rotating parts. It doesn't need a lot of change every year, every 2 years. Most of it is steel structure, drying conduits, heat exchangers that are built once and that are there for 35 years. So this is the major difference to understand that when you are comparing Exergy PSSD with competing technology, conventional technologies, do consider the entire thing on CapEx side as well. Dryer, TSP, RTO, filters, firefighting equipment, explosion protection equipment, all kinds of media. The land that you need for that to install, you can list everything here. But I think you have understood before, there are a lot more things that we need less of compared to what others need. Water recovery could be very important. Water footprint could be absolutely reduced when you can recover all the water from the biomass, which is an important aspect as well, which you cannot do from the other technologies. It all ends up in the air and also becomes vapor in the atmosphere. Yeah, if we have any questions from the previous or other parts we need to open the discussion, we of course are open for that at the moment.
So feel free to send in your questions at the little box that you can see, and we will answer them. I can see that we got a question here. It says, does this technology have a broad spectrum of different possible final product dryness?
Yes, it does. We can maintain dryness from the levels, let's say, whatever you need on the lower end of it, to almost non-measurable moisture content in the final biomass. So we can go up to 99.5% dryness if it is required for other processes that demand that. In some cases, we built one plant such where the moisture is not measurable. So yes, we can control the moisture in a wide range. It's not a problem.
Let's see. Do we have any other questions? As I said, you are free to contact us via phone or email or post if you want to as well. And we will see you all next time. Thank you for listening to our webinar today. And as I said before, this will be recorded, so you will be able to watch it later as well. Thank you. Bye.